Cool.
Nice.
So let's give it one more second, and then we can jump in. In the meantime, I also brought with me 6 hats. So for the folks who got here really early, if you want a hat, I can give you a hat.
Yeah. You guys want?
Does anyone really want a hat very badly? Okay, there we go. We got some in the back, so I'll throw them out.
Good catch. Nice.
All right, we got one.
For the folks in the back.
Okay. There's a few over here who are all vying for it, so I'm going to go.
Well,
Okay, there we go. All right. Now I've got Idan's laptop. That's the next thing we got going.
great trade secrets in there. Yes.
If you can figure out the password, then you can have it. Yeah, I think we got a few more folks in the outskirts, so just get comfortable. Come on in if you guys want. There's a bunch of space over here.
So I really do want to be here, but there's another session at 3 o'clock. Can we make exits are
Oh yes.
Okay, yes. And if folks need to leave mid-session, please let them through. Okay.
Yes. Please,
So,
make sure there's room. Yep. All
should we
right.
get things kicked off?
Sure, we can get started. I think everyone's here.
Okay, great. Well, first off, hi. It's great to see everyone. I hope everyone's out of their food coma from lunch. So this is a talk that's going to be about generative AI. I know that's been a really hot topic recently. We wanted to take a sort of a different approach to how most folks are thinking about it. Instead of talking about procurement tools specifically, we thought, okay, it could be interesting to see, okay, in the last 18 months, there's been an absolute explosion in the usage of AI. So why is that happening? What is generative AI? What are LLMs? And where is it going in the next few years? And then some practical applications that you could think about for your own company. So just a quick overview of what we're going to do. The first thing is we're going to talk about, okay, how do we get here? The history of LLMs. What can they do today? What can't they do? What are the changes that we expect that they're going to make in the future? And then what's the timeline for that sort of incremental progress toward a more advanced systems? And then fourth, just some practical tips for how to use AI in your organization. And a quick disclaimer, when you're watching this down the line, this content may be out of date, right? This space is moving extremely fast. So we could either look like geniuses and in 2 years, all of these predictions are true, or in 2 months, we could be comedically off. So that's just a quick disclaimer. A quick about us as well. My name is Spencer. I'm the CEO and co-founder of LightSource. We are an AI native source to contract platform. You've probably seen our enormous banner and the money and coins we've been dropping all over the conference. But by way of background, I actually spent most of my career at Tesla, where I helped lead the Model 3 program, Tesla's first mass market EV, and then Waymo, Google's self-driving car program, where I met Idan, who was at Google X and Google Research. Broadly, Google Research is the organization within Google that actually did the foundational research behind all of the chat GPT models that we see today. And so I'm very excited to have a bona fide expert with us sort of talking about that. So with that, I think we'll dive in, and I'll pass it off to Idan to give a little bit of a history of LLMs. Thanks, man.
Thanks, Spencer. So before we get started with how we use LLMs and how you can use LLMs in your procurement, I think it's kind of important to understand how we got here, and that really shapes how we understand how we use them. So we have to first understand what the L, and the M means in LLMs, and we'll start with the M actually. So the first thing is M stands for model. Model means making sense of noise. So let's say we have this data here on the right where we're mapping out heights versus weights, and we're trying to make a prediction and say, okay, I'm a carnival guesser of heights and weights, and I do data science as a part-time job, and I'm trying to optimize my job. So I'm trying to figure out, okay, how do I do this? Well, as a layperson, you're going to go ahead and draw a trend line, and a trend line, for all intents and purposes, is a very simple model. It's me saying, okay, when I look beyond the data that I have on my graph already, where am I likely to see more data points, right? Super simple stuff that people likely already know. So let's say we're trying to guess these 2 additional points over here. What's going to be the weight of someone who's 62.5 inches or someone who's 73 inches? Well, we're able to use our trend line and make a little guess and say, oh, they're probably going to be 100 something pounds. And when we add the rest of the data into the picture, we see that this is exactly what we're getting. So obviously this is a super simple model, right? It's just a line. And ultimately, what these language models are doing is not too different. They're making predictions. And so now we introduce the first L of our LLM, which is language models, or our LM here. And a language model is basically just predicting the next word in a sentence. So instead of predicting height and weight, we're predicting the next word in the text. And so here we have a little example, and they're not always correct. They're sometimes saying things that are a little silly. And so that's what our language model is. It's just the next word prediction. So now we're going to skip 150 years of research, because that's a lot of stuff that happened between now and then. And we're going to take a look at a little bit of a timeline, an abridged timeline of basically how we went from, I can guess sort of the next word, I can draw a trend line, to GPT is taking over the world and getting rid of our jobs, or all the fear-mongering that's happening. So basically in the 40s, we started using computers, or trying to use computers, to really understand and classify data, make predictions. So that's back in the time when men dressed in suits played around with tools that looked really scary, and ultimately they were able to figure out what's a dog and what's a cat. That's really what we're showing over here, is that they've got these simple models. They're able to draw a line between two categories. It's not super powerful, but very interesting foundational research. Cut to 2010, because nothing happened between 1943 and 2010. And in 2010, that's when basically there was a culmination of a lot of research, both in machine learning, AI, and also in computer hardware, that allowed us to finally make machine learning viable. Up until this point, we had these ideas and we wanted to execute them, but we just did not have fast enough computers to reasonably do it in a reasonable amount of time. So magically, through the use of this other technology that was developed for an entirely different purpose. So you could play video games at home in parallel. That turned out to be super useful for training AI, because it was doing the same sort of math. And we got these amazing leap forward in what was called convolutional neural nets. This doesn't matter too much exactly what that means. Long story short, suddenly we have these models that, better than any other model in the past, were able to identify, that's a container ship, 90% accuracy. That's a leopard, or is it a jaguar? I'm not sure. The model's probably better than I am at guessing what that is. That was a huge leap forward, and suddenly you've got this boom of all this AI research happening. And I want you to pay attention that this timeline really condenses from 2014 to 2022, no time at all for this huge amount of research. Our next big milestone is 2014. You folks better probably remember that Google Translate used to be this kind of clunky joke that would be I look at this website, is this Google translated? It's terrible. But in 2014, there was a seminal research paper where they were basically able to use these new techniques that we developed previously using these GPUs to build these models where suddenly Translate was so good. And the way that it was so good is it was using this nuance here where basically not the input sequence and the output sequence aren't exactly aligned, right? If I have in French and English, I love you, je t'aime, but the love and you is flipped around. So when I'm predicting my next word, that next word prediction that we were looking at a second ago, sorry, this might be a little bit too in the weeds. Just understand that this is a huge shift to focusing on what section of the sentence mattered the most. And they call this thing attention. This model was really powerful, amazing Google Translate, but it was unbelievably expensive to run. So there was a lot of research done to make this cheaper. In 2017, they created this thing called Transformer, which was a special version of Google Translate that was much cheaper to run. And the only thing you really need to know about Transformer, this is super scary, don't worry about it, is that it's the T of GPT. So next time someone asks you that in a trivia question, now you know it stands for Transformer, not Optimus Prime, really boring math. And so the Transformer was a way cheaper way of doing Google Translate, and they realized that they could train it much faster. And that's when things accelerated. So in 2018, the folks at OpenAI, they published this paper called GPT-2, and basically GPT stands for Generative Pre-trained Transformer, second version. And what they realized is that instead of training it to do translate, give me a sentence in one language, give me a sentence in another language, they said, have the whole internet and just guess the next word. And some magical things started to happen as that model became bigger and bigger and bigger. And so that's where the generative and pre-trained comes from. It's saying, okay, I've pre-trained this on the entirety of the internet, and it's generating new text instead of doing translation. And GPT-2 was amazing when it came out. It's still really funny. I recommend checking out some of the old examples. They're a lot less impressive than the modern day GPT, but it's fun to go back and see sort of the silly mistakes that it makes. And then obviously in 2022, we all remember when this happened. Everyone got their hands on GPT, ChatGPT, the latest models from OpenAI, and obviously the Terminators took over, and now everyone's doomed. So that's a brief history of LLMs, and that's how we got here. It's an interesting story from Google Translate to AI is taking over, but it's surprising. Just as a quick show of hands before we get into the LLM basics section, how many folks here use some form of AI or LLM in their work already? It's a good portion of people, so this is great. This is hopefully not going to be, for you guys, this won't be revolutionary, this next section, but hopefully it helps you think about how you use it. Anyone who raised their hand right now, by the way, just know that you're in like the 95th percentile of like sophistication in terms of people using technology for their tools. So that's already amazing stuff. So this is how most people are using LLMs nowadays, right? So I've got this question, and I say, what does a supplier need for an ISO 9000 certification, right? That's like our quality certification standard sort of stuff. And boom, GPT gives you this amazing breadth of insights. And wow, that's just incredible. Like, I think it's hard to understate like how amazing technology has gotten that I can just put in those words into a computer and it spits out a level of information that even if I just asked a random coworker, unless they were literally working on an ISO 9000 specification a month ago, they have no idea, right? Like, and it's giving you this overview. Now, I think that at the same time, it's worth like digging into like what is the actual output that it gave me, right? It's a little verbose, it's a little repetitive, it's saying the same thing more than once. Maybe it's a little surface level, and maybe it's not focusing on the right things necessarily. Like a human might tell me specifically the different sections of an ISO 9000, but that could be our fault, right? Maybe it's a bad question. So what do we do usually? We go back into our chat and we say, okay, give me some more specific information. So for ISO 9001, what section is about performance evaluation, and what do you think is the most important all-knowing AI? And it says, in ISO 9000 2015, for some reason I picked 2015, section 9 is about performance, and the most important thing is customer satisfaction, because the AI knows that the customer is always right. But that might not actually be the right answer, right? Like, this answer is opinionated, but whose opinion is it, right? It's being culled from the entire internet, but when you ask your coworker, you know their experience, you know what company they've come from, you know who they are as a person. When GPT spits this out, it's hard to really understand where it got this information and how trustworthy it is. So that's a big question. And then secondly, like we said, we're looking at a little bit of stale data, right? It's from 2015. ISO 2024 has been out for a few months, so why can't it show me the latest and greatest information? And so that kind of leads us into this next section of sort of what are the challenges right now with these systems? And so the biggest challenges, we're separating them into two sections, technical hurdles and then more structural hurdles. So the big technical hurdles right now are information staleness, which we just saw, logic, reasoning, and math. Don't ask GPT to do your math homework. It probably can do pretty well, but as soon as the calculations get a little complex, you might as well ask your toddler. And then multimodal processing is having the models be able to take in images and videos and audio and be able to understand and synthesize all of that. And then lastly, context size or context windows, which is something that is really important to understand, is that these models can only take in a certain amount of text before they have to spit out an output. And that means that you can't put in your entire database. Like, let's say you even have 100 documents that you're looking at, you can't put all of that into the model and have it process that. There are a few workarounds for these sorts of technical hurdles. So first, let's look at information staleness. These models are unbelievably expensive to train, and they require a lot of technical expertise to make progress. Sam Altman of OpenAI said that GPT-4 costs around $100 million to train just that one model, and that took about 2,600 hours of server time, which is quite a lot. And you're oftentimes at the mercy of these companies that are training these models, right? They're going to release these models when they think they're ready to release them. And so you might be running on a model that was trained on data from 2019 up until they say, okay, this model is good for me to deploy. There are workarounds to this. So we're not going to go into super depth on this because this is, we're trying to not go too deep here. But just know that there's new technologies called knowledge bases, or RAG. You'll see that acronym come up from time to time. And fine-tuning, which are for very sophisticated organizations that want to use these models on their own data. So that's basically connecting your models to your databases or retraining the models afterwards. I'll hand it over to Spencer to talk a little bit about structural challenges. Here you go.
Thanks, Yudan. So just to talk a bit about some of the structural challenges, The first is power. Power. So power and energy. The amount of power it took to train ChatGPT 4 was equivalent to the amount required to power 1,400 homes for a year. So that's a lot of energy. In fact, Microsoft allegedly has a program now to look into nuclear energy specifically for powering data centers. So that could be an interesting thing to keep an eye on. Environmental, of course, there's environmental implications of all of this, emitting greenhouse gas or worse. Compute capacity. So there's a huge constraint on, I'm sure a lot of folks here have heard about the chip shortage from COVID. Well, that was more a supply chain disruption. Now we're dealing with a demand shock. So NVIDIA is a maker of GPUs. It is extremely hard to get the H100 chip, which is their current GPU for data centers. They're fabless. They make a lot of their materials at TSMC. So there's also this long lead time capital equipment concern related to how do we invest and how are things going to pan out with Taiwan versus US versus China relations. So all things to think about. Copyright and legal. This is sort of the unsung Achilles heel of a lot of these LLM models, which is they're trained on information like the New York Times articles. And so if it outputs an answer, should that be material that's copyrighted by the New York Times? Is it their information? Or is it just a generic derivative, this word on stage, derivative work, sort of like if a musician listened to B.B. King growing up and then goes and plays in a blues band, maybe they were influenced by B.B. King, but they're not ripping off his stuff directly. User interfaces. This is actually another huge one that people don't think about. Chat, like I think a few folks raised their hands. ChatGPT is a good user interface for about 50% of the applications that you might want to do. But chat is actually not a perfect interface for a lot of things, right? So if you wanted to run automated RFQs to your suppliers, you can't just type that into chat. It's going to tell you a process that you can use outside of it, but it doesn't have the arms and legs needed to do it. And then the final one, this is a subtle one, model collapse. So the concept here is basically as there's more AI-generated content on the internet, that's being fed back into training new models. So it becomes garbage in, garbage out, right? So if you start training new models on old model output, then you're going to get this sort of self-reinforcing model collapse. Okay, so we're going to talk a bit about the AI progression. These are the I feel like quite controversial slides at this point. So we're going to talk about what's possible today, what's likely to be possible in 3 years, 5 years, and 20 years plus. So today, we all know what's possible. You can make any image, photorealistic drawing, illustration, cartoon. The second, it's very good at answering your questions, sort of an alternative to Google search. The third is help me evaluate this document. So language model, right? They're not numeric models, they're language models. So anything that's a language task, LLMs are actually quite good at. Things like drafting emails or memos, again, very good. All right, 3 years from now, I think it is safe to say that every single SaaS provider in any business space is going to be AI powered, right? So today, I think a lot of times you have SaaS tools, like traditional procurement SaaS tools, and then their AI is that they also have a chatbot you can talk to completely unrelated to the app. In the future, it's going to be that all the functionality within the app is actually powered by AI and these foundation models. Pre-built integrations to knowledge bases, again, like if you have a data lake or a data warehouse that your company is managing, be able to query your internal documents without needing to use the context window. Making really good content, so like a full animated video with language, with speech, animations, that's actually really good. I think in 3 years that'll be possible. Multimodal interfaces, so pulling in information that's not just text, but also audio, video, all the senses that the human body kind of has. You fuse that stuff together in your brain. Models in the long term will be able to do the same exact thing. All right, in 5 years, we're moving into the world of ensemble models or agents. So the idea is that you can actually have, I like to joke that it's sort of an army of interns that will be able to help you do your work for you. The second thing that could be kind of interesting is when these models become interoperable, that they can actually communicate with one another, either on a unified protocol or that they could communicate with one another about how to interact as stage 1 and then stage 2 actually do it. And then in 5 years, you'll still be 3 years away from finishing your S4 implementation. So that's my other prediction. So 20 plus years from now, I mean, at this point, it's more science fiction than anything else. I think it's not unrealistic to expect that in 20 years, These models will be able to do all of our work for us and all of our bosses' work for us as well. I don't think it means that we're going to be out of jobs. I think what it means is that our jobs are going to become different. And the people who are embracing technology and are using it really strategically are going to get supercharged, not left behind. That's typically the way it works. And then I think that the other thing that could be also interesting is a lot of models could consolidate. So instead of having one AI doing HR and accounting and finance, you can have one model that's really good, and why can it not fulfill actually a whole range of business functions? And then this final question mark with the shrug is AGI, which is artificial general intelligence.
Yeah.
So that's the singularity. Now we're getting into religion. All right. So next we're going to talk a bit about what to actually do with AI today. Like, I want everyone here to be able to go back home in Vegas or outside of Vegas and take some ideas back with them that they can bring to their orgs that are actionable. So the first thing is that we have a range of foundational models. The famous ones are OpenAI. Anthropic is very popular. They have this Claude Opus 3 model that's great but expensive. Google has Bard, which is now Gemini. Meta just open sourced Llama 3, which is their approach to basically distributing their model for free. There's a lot of others. I'm sure others will come up. I also want to draw a distinction between AI and automation. This is something that I feel doesn't get talked enough about a lot, or at least not in a sophisticated way. I like to think about, again, the analogy of the robot body versus the robot brain. The brain alone can do some thinking, but without the body, it actually can't take action. It can't do anything, right? And so the body is the automation. That's the input-output system that's doing stuff, taking action. And then the brain is actually a mixture of what will be LLMs, I promise that's not me, LLMs and automation pulled together for some kind of business logic. But 90% of the work is still going to be plumbing, right? If you want a tool that goes and automatically sources your category for you, it's not through ChatGPT. It's going to be a lot of interconnected systems responding, talking. That's kind of what we do. Okay, so this is a little bit of a framework that I kind of want to share really quickly about how to think about AI applications in your own organization. So on the bottom over here, we have one-off versus frequent use. So is it something you're doing one time, or is it something you're doing every day or every week? It's your daily bread. On the y-axis, we have, is it simple, clean data, or dirty, complex data? So let's just start with each quadrant. This is a framework. You guys can take photos of this. You don't even have to give us credit for it. It ain't no thing but a chicken wing, okay? So chat interface. One-off, chat interface. So you've clean, simple data, and it's one-off. Just go to ChatGPT and use the chat interface. Then let's say that you have frequent use. Again, clean data. It's frequent use of really clean data. Use automation tools. If you have clean data, you know what you're trying to put in, you know what you're trying to get out, don't worry about using some kind of AI system. Your data is good. All you need is the piping. Let's say you have complex, dirty data, and you're only doing it one time. Like, you just want a one-time task. Then what I would say is use a manual process with AI tools. Because likelihood is you're going to have to actually check the information that's coming out and maybe even spar with the AI to get it to give you the right result. And even then, still look at it, right? And then the final thing is dirty data or complex data that's being used frequently. So this is like the things that we're doing all the time, but our data is not good. This is where you need to look at softwares that are purpose-built with embedded AI. And that's something like LightSource or some of the other providers that are around today. Now I'm going to pass it back to Don. He's going to talk a little bit more about the AI problem-solving guide in depth. And then after that, we're going to actually open up to questions. So if folks, there is no right or wrong level of sophistication. We want to hear everything that you guys have to ask about.
Yep.
So clicking into that little matrix of how we should think about solving these problems, we wrote down a little guide that can help you attack the various challenges that you might have in your organization and think about how to add AI to your organization. So the first step, as always, is admitting you have a problem, or identifying that there is a problem and identifying what the problem that's useful. So usually you want a problem that's relevant for LLMs, so textual processing, content generation, summarization, and you have to really figure out, is this a problem, what the stakes are for mistakes, right? Because these models, every time you talk to a chat window at the bottom, it says, this can probably make mistakes. So you have to decide, do I have a chance to correct it, or do I not care if a mistake goes through, which is okay. Then we collect inputs and outputs. So here you might say, why do I need this? Well, how do you know you actually solved your problem if you haven't compared what you wanted to start with and what you wanted to get out? So always collect inputs and outputs. Pick a model. So this might seem like, where's this coming from? I just use ChatGPT. I've never heard of other models. Well, by default, most of these chat models will actually take all the data that you're putting into it and then use it again for their own training. So unless you want your proprietary data being used and exported for other people to use, you probably want to take a look at enterprise environments or self-hosting your own model. Four, constructing prompts. So prompts are great nowadays. There's great capability for sort of human-based input, but it turns out you can get a lot better results if you do a couple of tricks. And there's a lot of resources online for templates for how to structure these prompts. And we're not going to go into super depth on that one, but just let you know that that exists. And then lastly, okay, how do I bring in IT into this mix? Do I need to bring IT into this mix? Hopefully not, right? That's always a pain. So let's just look at two examples, one really simple one and one complex one. So a simple example might be email drafting, right? My problem is that there's a lot of back and forth communication. I want to communicate effectively. Well, my examples are I've got this email, this terrible email that I wrote and I can't believe I sent, and then the output, a much nicer email that hopefully will get much better results for my negotiation. I look at my model and I say, okay, this is something where I'm going to be sparring with the model. I want to get the tone right. And there's no sensitive information really that you can glean from this. So I'm just going to go directly to one of these various chats that are available. ChatGPT, Claude, Opus, Gemini. I'm just going to use a simple interactive prompt like a human. I would just ask it to talk. And then I'm not going to bother with an IT integration, right? Though do be aware that there are a lot of solutions on the horizon, especially from like Microsoft with Outlook and for Google Workspaces for integrating these models directly into your email clients. So that's effectively like an IT integration. A more complex example could be something like identifying contract opportunities. So let's say we've got this huge database of all thousands of supplier contracts, and we want to, we need to bring down our costs. So we need to figure out, okay, what are opportunities to renegotiate some of these contracts? We have these contracts that are expiring. Do we have these prices that no longer match the current market rates? And so we collect our examples. This one, it's especially important to find good quality, but you don't need too many examples so that you can start really structuring, here's the input that I want, here's the output that I want. Usually you can get this from maybe some report or investigation effort that's been done on your team, or if you're in the middle of migration to like a contract lifecycle management. Pick a model. Here the information is super sensitive, super proprietary, obviously all our contracting information. So this is where we're gonna either talk to IT, do self-hosting, or opt for one of the enterprise systems. For our prompt templates, we'll use XML-like tags. This is, again, don't worry exactly what this means, but just know that it exists, and it's something that you may need to do if you're doing a very advanced sort of prompting. And then lastly, if you're doing this as a one-off operation, again, you may not need IT involved at all, but if this is something that you're going to be monitoring continuously, and you say, actually, you want an AI agent working on our behalf, checking if we have opportunities to find tons of savings, and this is when you want to bring in IT early, make sure that you're structuring your inputs and your outputs in a way that IT can consume, and you can build out this amazing automation. And as you can see, this can get really hairy really, really fast. And so this is where really you can opt for something simpler, which is an AI native solution. So we're eons away from GPT come and do all my work for me, and also run my whole company and find all the savings. And interfaces are still a problem. Getting all that data into the system still really hard. And you have to make sure that your data is still high quality, because again, it's garbage in, garbage out. They can help, but they are not miracle workers. So it's all about using thoughtfully designed systems, making sure that you have high quality data, and having these sort of embedded AI solutions to really help address these difficult challenges, make life a whole lot easier. So now we'll open the floor for some Q&A. Sorry? Sorry. The first L is for large. It's just very big. It's when they did GPT-2, they realized that the bigger they made the model, the more compute they threw at it, the smarter it got and the more amazing things it did. So you'll often see when they report on a model, they'll say it'll have 70 billion parameters or 9 billion parameters. That's just the size of it. There.
Yeah, we'll just pass around a mic for folks who have questions.
Yes.
So can you speak about how they're running out of data to train some of these models, especially after GPT-4 and GPT-5? They're basically running out of data on the internet, and so you see challenges with that?
Yeah. It's a great question. So model collapse is a totally new area that people are researching. It's this whole idea that if you have AI trained on AI data, then it starts forgetting things. All of Wikipedia is, you can fit it on a thumb drive, so there is a lack of data. I think this is something that is being actively researched right now, and people know that it's an issue, and by the virtue of them knowing that it's an issue, they're actively trying to address it. So I think that you should expect from the next few iterations of models that this likely won't really affect things severely. And the models that we have right now are still extremely powerful. We'll use these alternative techniques for bringing data freshness as well. Yeah. Any other questions?
Just a question. What does the role of machine look like in 3 to 5 years for sourcing for other industries as these models get better and better?
That's another excellent question.
Let's repeat the question.
Yes, so repeating the question is, what does the role of the human look like in sourcing or any other function over these next few years as AI development advances? So I think that we'll start seeing ourselves becoming more managers and editors. Spencer's analogy of this is a fleet of 100 interns that I'm dealing with is pretty apt. Like, you're still going to want to oversee the way that these models are interoperating, and you'll need to have an understanding of how these models interact. But you're going to be the one who receives all the information, synthesizes it, and then makes the ultimate decision. 20 years from now, models might be able to do that part too, but in the next 5 years, that's sort of the transition that we're seeing, sort of like upskilling, much more movement towards editorial and management of agents. Would you like to add to that? Yeah, go ahead.
Yeah, thanks. And just to build on what Idan's saying, I can't emphasize enough that, if you are able to do the work of 50 people, you should be compensated like 50 people. That's my true biased opinion.
Yep.
And so I think the ability to harness these tools effectively, I think that it's not just about staying ahead of the curve. I think it actually will make people over time a lot more valuable.
Yep.
Yeah, great question though. So yeah, hands up for the next one, and you can pass the mic.
Oh, we're at time.
I think we have time for just one more question. Is that all right? Okay, we've got one more opportunity for questions. So who wants it?
Okay.
All right, we got one back there.
Just in general, if you're trying to do research and find, I have a problem, I think ChatGPT is the type of solution. Do you guys have any resources you recommend people be aware of to look into for that type of thing if they want to dive further but don't have a great understanding of that?
Do you have a set of things?
I think that there's
the question was, let's say that you have a problem that you think something like ChatGPT could help solve. Do we have any resources that we think are helpful to maybe engage with that problem or learn about where people should go? The easiest answer, to be honest, I think there's a lot of things online. The answers are not perfect yet. I'm going to also say this for just the folks who are still here, the dedicated, we'll stay till exactly 3 people. Feel free to send me or Idan an email. If you have a problem that you're trying to solve and you want to figure out, okay, what is possible? What should I be looking at? And can I prototype a solution? Like, we're people who are passionate about this. I mean, the reason why we're here is because we wanted to meet all of you here. And so that's what we're doing by trying to share what we have experience with, what we know. But it doesn't have to end like when we exit this fake shrubbery.
Yeah.
So anyway, that'd be my answer. But Idan, do you know any resources that are directly useful?
I'll just say that this is a very quickly evolving space, and each new model has entirely different set of behaviors and recommendations for it. So including Anthropic just released this whole batch of Claude 3 models. They have their own guidelines on how you should use the big one Opus versus the medium-sized one Sonnet versus the tiny one Haiku. So I would go directly to the sources of these various research companies. They have a lot of great explainers. I'd also say just dive headfirst into the prototyping. Like, take your data and make sure it's not sensitive and proprietary, and just go and try to see what happens. Because you can get 80% of the way there, usually just by explaining it in a human-friendly way. And then we can look at like the specific details of like prompting and prompt templates to really get it that extra 20% faster. But yeah, it's a great question.
And I think with that, we'll wrap it up. But thank you so much, Idan, for taking the time to come down to Las Vegas, and for all of you guys for being here. It was a real joy. And come say hi at the booth, and if you want to grab some free swag, please do it. And thank you to the organizers again. It was a real joy to speak in front of you today. Thank you. Thank you. Nice.
Thank you very much.
Thank you so much. Yeah, I really appreciate it.
Thank you. Thank you.
Yeah,
Yes, our
sure,
booth is
sure,
right
sure.
over there
Let's
for
do it. Let's do
LightSource.
it. What do you think?
Sorry?
I was looking at you when I needed,
Yeah,
when I
we'll see you in
needed
a second.
comfort, actually.
Sorry?
I was like,
No,